guys. Sorry, everybody else has been doing a great job because I'm kind of pacing back and forth across the stage as they give their talk, and I'm not going to do that without a lot of like hopping, so I'll mostly just stand here. My talk is called Deathmatch, Bundler versus Ruby Gems, and I'm André Arko. I'm indirect on basically all of the internet things, and I work at Cloud City Development in San Francisco, where we build web applications, mostly using Ruby on Rails. I, as PJ said, am the lead developer on Bundler, and this talk is about Bundler versus Ruby Gems and how I kind of inadvertently am the root cause of a distributed denial of service attack against rubygems.org that took it completely down for multiple days. Sorry, guys. Not totally the best, I realize. Oh man, and I just discovered that Keynote is not showing any of my notes. Hang on one second. Screens. This is what I get for not having actively done my slideshow on my computer already. Oh my God. Okay, sorry about that. So, the story of how I took down rubygems.org and how we tried to fix it later starts with Bundler 1.0, which came out a really long time ago now on August 30th in 2010. But it was 1.0, so yay, it actually worked. It was amazing. And as you guys are totally super aware now, the awesome thing about Bundler is that you could run bundle install, which was a totally new and basically unheard of software concept before that. It was pretty great. So the terrible thing about that was that once you ran bundle install, it would install and it would install and it would install, and it would take a really, really long time. Yeah, there's only so much you can do about that. So what seemed like 10 minutes after Bundler 1.0 came out, I had someone on the internet send me this. Very creative developer level photoshopping there. And so, I mean, I wasn't totally sure what to make of this. Like, it seems like it's kind of awesome that they're getting to have a sword fight while sliding on chairs. But what I actually took from that was that Rubyists have really high expectations for responsiveness and speed as long as the command they're running is not Rails console. So we were sad that Bundler was slow. Slowness makes us sad. We said, surely we can do better than this. It takes like 10 years. So Nick Quaranto, who wrote the Rails app that currently powers rubygems.org, said, hey, I have an idea. Let's build an API that Bundler can call that doesn't send the entire list, and this is the great thing about Ruby Gems. If you want to install a gem, it downloads every gem that's ever existed, not the entire thing, but a list. And there's 62,000 gems now, and there's roughly 750,000 versions of those 62,000 gems. So, it's not only gzipped, it's marshaled because it's an array that's marshaled and then gzipped. And oh my God, yeah, I'm sorry. So let's not do that was the punchline. So Nick basically came to the Bundler team and said, hey, what can I give you guys that will be less than that? And we said, well, you could just tell us about the gems that we actually care about. And he said, hey, that sounds like a great idea. So we did that. And it only took a couple of weeks to like get that implemented and start trying to use it. And oh my God, it was so much faster. It was super, super great. What happened was Bundler would just say to Ruby Gems, hey, just tell me about the gems that are actually in the gem file. And then it would find out about those gems, children, and it would say, hey, tell me about those gems. What do they need? And after a few times of this, which is all of the individual dots that you see appear while Bundle is running, it knows all of the gems that it needs to install, and then it just downloads and installs those gems. In some preliminary testing, it was way faster. on like a small, I think this test was with a gem file that just had the Rails gem in it, but Rails has a lot of dependencies. It was a lot faster, like 8 seconds instead of 32 seconds. That produced all kinds of new problems, because if you've been assuming that you already have information about every gem that exists locally, you have to do a bunch of different things to like not have that information anymore. But we eventually worked out all of those bugs. And on March 7th, 2012, which, note, that's a really long time for a 0.1 release change, Bundler 1.1 came out, and it used the API. Hooray! It was really exciting. So that was March. There was a thing we didn't realize because no one installs pre-release gems. And the thing that we didn't realize was API requests that rubygems.org is now providing are an unbelievable, gigantic pile of work. So back in 2012, rubygems.org, the entire site, ran on a single VPS in Rackspace, which included Postgres and Unicorn and Redis, and every single thing that the entire rubygems.org site did was just that one VPS. I didn't actually know that when we set this up. You're about to find out how I found out about that. So it turns out that the API was actually a lot more complicated than what it had ever done before that, because it had to ask Postgres about just those gems, and then it had to serialize that into Marshall or JSON, and then it had to send it to Redis so that it could cache it, and then it had to send it down the pipe, and all of these requests and marshalling and all of these things took a lot more CPU than just sending a single 302 redirect to CloudFront where the gigantic Marshall gzip file was stored, which is all that rubygems.org had ever had to do before. I honestly have no idea how no one realized this, but as the months wore on, lots of people eventually upgraded to Bundler 1.1 because it was actually way, way, way faster, and they were very motivated. So more people are using the Bundler API every day, and people are writing blog posts saying, this is the best thing ever, it takes so many fewer seconds, and you don't just sit there staring at a thing that says fetching for what seems like half of your lifetime. And so I was like, yay, I'm so glad it works, and everything is awesome and better, and everything's happy, and you know how that cliche goes. So let me just take a second here, and I don't think anyone else is going to do this, but I'm going to give you a dramatic reenactment of the rubygems.org server room as a time lapse using emoji. So here's February. Here's March. This is when Bundler 1.1 came out. Here's September. 6 months later, it was a little worse. This is October. So in October, so many people were using Bundler 1.1 every day that the API requests actually needed more CPU time than the entire rubygems.org server infrastructure, which I did not realize was one VPS, had available to serve requests, and the box just went down. There was no more API. That turned out to not be as terrible as it could have been, but while trying to bring it back up, they were like, oh, it fell over, we don't know why, we'll just bring it back up. And then that lasted for approximately 3 seconds until everyone hit the up arrow and pushed enter on bundle install again, and then it went right back down. After, I honestly don't remember how long it took, but I think it was maybe like 2 days later, they were finally like, oh, all of the traffic that is killing this server is just the Bundler API, so we can make it stay up if all we do is turn the Bundler API completely off. I was like, oh, thank you. So people started filing lots of tickets on Bundler saying, it's broken, it says the API didn't work. And that went on for, I don't know, probably another few days. And then that's when I found out from the rubygems.org team that it was never going to come back. So in the end, after there was a lot more of this, and as I started getting tickets, and I was like, oh no, we're back where we were before. Well, no, we actually weren't back where we were before, because by this time, Bundler had been so awesome that way more people were using it. That was not an improvement when everything went sideways. Crap. Since basically it turns out the bundler team was the only people who actually cared about the bundler API being down, we said, well, I guess we shouldn't wait around for the RubyGems team to fix this. We will build a replacement ourselves. We decided to just re-implement the API part by itself as a standalone app. We wound up using Sinatra, thanks Constantine, wherever you are. And Heroku, because they have a lot of bundlers, bundlerites, I don't know, for people who use bundler. And because the other lead on the bundler project is Terrence Lee, who runs the Ruby stack at Heroku. Heroku offered to provide hosting for our standalone bundler API. And we made it super simple, hosted on Heroku, tiny Sinatra app, it's like 25 lines. And we just used Heroku's Postgres hosting because Rubyists.org already used Postgres, so we could just like ship a copy of the database over and start going. So after we built that, which was the super easy part, we had some questions. Is it actually going to work this time? Since we don't actually know if it's going to work, because last time we thought it would work, and that turned out to not be true after 6 months. And we aren't going to get 6 months to have gradual build-up this time. We're going to turn the switch, and all 10,000, I don't actually know the number, all the bajillions of people who are using Bundler 1.1 are just going to like hit us all at once. And we would really like to not have everything fall over this time. So that, of course, led to the questions like, how is this version of the API bad? Because we now know the ways that the old version was bad, and they were very, very bad ways it was bad. And finally, like, if it's bad, can it be better? And kind of even beyond that, like, had we overdone it? Like, we pre-allocated dozens of Heroku dynos, and then I realized that I was using thousands and thousands of dollars of Terrence's budget and felt kind of bad. So in order to answer any of those questions, we needed measurements. And so the only way, not just to know if it would work, but also to know if it was going to keep working, was to monitor it. So we set up a bunch of logging and instrumentation stuff. And we measure a ton of things. For how tiny the service is, we measure a ridiculous amount of stuff. Librato, Metrics, and Papertrail both donated accounts for Bundler API to use, and we used the crap out of them. I got a Librato bill a couple months ago that was comped that was like maybe $2,500 because we sent them so many measurements. It was fun times. So Librato tracks all of the metrics coming out of our code as it runs, which lets us do some pretty fancy and cool stuff. We have like load measurements and performance measurements and size measurements and count measurements and all kinds of great things. And actually the Bundler dashboard is currently the demo dashboard. If you go to librato.com, the link on the page that says try a dashboard is the Bundler dashboard. So if you want to know how Bundler API is doing, you can just click that link. We also use Papertrail, which is basically a log aggregator, but it's a really nice log aggregator. If you guys aren't using log aggregators, I super, super recommend Papertrail, because having a single place where every single line of logging from all of your app servers and database servers and whatever utility servers and background jobs all show up, and you can say, just show me the background and foreground log lines that happened at this time with this string in it. Like, it's pretty amazing to jump time-wise and filter and search and all of those things. So the practical upshot of all this is that once we had measured things, we were able to figure some stuff out. Since we hadn't had any visibility into how Bundler API worked when it was hosted on rubyists.org, we started to discover some really interesting stuff. All of the stats that we inherited from the rubyists.org team was, they said requests usually took 2 seconds and sometimes took up to 20 seconds each, which seemed bad, and I was hoping we could do better than that. So we made some discoveries once we had everything instrumented, and I'm going to tell you the most surprising ones. This is not one of the surprising ones. So Postgres is actually pretty fast. Our data set was really small, completely uncompressed. The entire data set is like 400 megabytes. It fit in memory, no problem. Queries were returning in like 5 to 15 milliseconds. We instrumented the entire app stack, and our median response time was around 80 milliseconds, like pretty good. 95th percentile responses were around 600 milliseconds. Like, it was way, way, way better than 20 seconds, which was what we were trying to avoid. As we were kind of experimenting, though, we discovered that big Postgres is way faster. So like Heroku has Postgres tiers, and you can say, I want a Postgres that can hold this much data. We don't have very much data, so we were using a pretty small Postgres, but Heroku will give you a huge Postgres on a giant box with super fast stuff, big processor, fast storage. So we massively over-provisioned our Postgres just to see if that would help, and it totally helped. Queries started returning about 5 times faster. They were down in like the 3 milliseconds per query range, which is super amazing when you think about the fact that they're not even running on the same box, and they were coming back in like 3 to 5 milliseconds. That's super, yeah, I was super impressed. So median response time dropped all the way down to 20 milliseconds. 95th percentile responses dropped all the way down to like 200, 220 milliseconds. Like, this is 2-ish orders of magnitude faster than before. Like, I'm really happy about that. The first super surprising discovery that we made was that caching responses in Redis is slow for us. I'm not going to say this blanketly, but like, that was super surprising to me. I was like, oh, we're caching. That should make everything faster, right? We don't have to re-render every response every time. Nope, didn't actually help. That cache didn't actually get used because it turns out that when the response depends on every single gem, nobody has gem files with the exact same set of gems in them, like basically ever. So like, it would speed up your request if you ran bundle install twice, but then bundler doesn't need to request all of those things if you run it twice. So this was actually a bad idea because it meant that we were wasting all of the milliseconds that every request spent sending the cached response to Redis where it would never be read out again. So we sped it up by taking Redis and caching out. The third discovery that we made is that threading is super, super great if you can do it. It's not super well known, although it's much more well known now than when I was doing this late last year. Heroku's router is not optimized for applications that have really slow responses. There was a big kerfluffle that maybe you guys heard about when Rap Genius decided that Heroku was evil and lying. I don't know if I'd go that far, but random routing, which is how Heroku currently does routing, super sucks if one of those dynos is just sitting there spending, say, whatever our 95th percentile was, serving a response. Requests can back up. If you get like 2 or 3 slow requests in a row, it's entirely possible that some bad random routing will get you requests that time out just because they got caught behind a bunch of slow requests. So if you do the math and you have slow requests, it turns out that you actually need hundreds of dynos to serve, like, say, 90% of the requests that in a theoretically optimal world would require 10 dynos. I couldn't actually afford hundreds of dynos, so I was trying to figure out how to make that not happen. So what we tried doing is hosting the Bundler API on the coolest, newest Ruby web server, Puma, which is actually pretty great. It allows you to run web servers with threading, and so it didn't actually matter that the routing was random because Puma could accept requests on threads, and every individual dyno could handle, I don't know, a couple dozen requests simultaneously, which was super cool. There was one problem with that, which was at the time there was a really subtle concurrency bug in Puma that meant that every once in a while, Puma itself, not our code, but the web server would develop a deadlock, and then it would keep accepting requests and never send any responses forever. So aside from manually killing that dyno, we didn't actually have a solution for that. So we wound up running on thin for 6 months, which doesn't have threading, and meant that we had to run like dozens of dynos where we really only actually needed like maybe 6. Eventually that bug in Puma was fixed, and I'm happy to report that Bundler API is back on Puma and threading is awesome, and holy crap, it's so much better, like from CPU load and number of dynos and basically every perspective you can think of. Like if you can run, like Puma will both let you do multi-threaded processes, but it will also let you do multiple processes like Unicorn. I highly recommend starting out with the multiple process option like Unicorn, and as quickly as possible doing whatever it is that you need to do to get your application threaded, because, and I say this especially if you run on Heroku, but like in general, routing is hard. Being able to accept lots of requests that are randomly routed is really, really good for like your application's performance. The fourth discovery that we made is that it's hard to tell how much capacity you need, it turns out. Other than everything's on fire, we know we don't have enough capacity. There's not actually a huge body of like Ruby application deployment knowledge around like, you need this much capacity to handle, you know, like here's how to tell how much capacity you need. We tried to use metrics to figure that out, but it turns out that metrics are also tricky. Heroku used to provide a header called dynos in use that just told you how many dynos were being used at the moment that that request was served. So we tried to use that to say, oh, all of the dynos we have allocated are getting used. I guess we need more dynos. But that number turns out to only be effectively a guess on Heroku's part rather than actually correct. And so they stopped offering it, and then we were back to, well, it's not on fire. I guess we have enough dynos. So, like, figuring out how much capacity we had and how much we needed was super difficult, and eventually what we settled on is Heroku's router actually like sends an error message anytime it tries to route a request to your application and your application says, I couldn't take that request. So that's kind of our proxy for things are gonna be on fire in a minute, but they're not just yet. So the combination of the monitoring that we already had made it kind of awesome to realize that we could just go to Papertrail and say, hey, anytime the Heroku router says this log line, send it to Librato so that we get a pretty graph. And then we went to Librato and we said, hey, Librato, anytime this graph goes above like 1 per minute, send it to PagerDuty. And then we told PagerDuty, hey, send us all emails and texts and phone calls and tell us that the world is ending so that we can actually add more dynos. Like, monitoring everything was basically the only way that we figured out how to make that work. So we're pretty sure now that we have enough dynos. And when we see that alert that tells us we are handling more requests than we actually have dynos to handle, that's when we know to add more. The last and super surprising discovery that I made while working on this one is that the response time metric that everyone uses, whether they're on New Relic or Librato, Rack, or like anything, that number, like here's the request time, that is a total lie. Thank you. So it is actually, in some senses, at least, a number that came from somewhere. Like it was not actually made up unless you're using almost Rack, as Constantine pointed out to everyone. In real Rack, that number is not made up, but it is not actually indicative of the amount of time that your users are spending waiting to get a response when they make a request. The only way to actually know how long it takes to make a request to your application and get a response back is to check it from the outside. We actually run a completely secondary application in a different region on Heroku that does nothing but sit around and every few seconds make a request to the main bundler API and send how long it took to Librato so that we can see a graph of how long it actually takes to make a request and get a response back. The reason it turns out why that number is basically always wrong is that your application only knows about the time between when it got the request and when it sent the response back. Unless you are running the smallest service in the world, like maybe rubygems.org, where that's a single box, there's tons of stuff happening that doesn't get timed by that metric, like say the Heroku router, or if you're not on Heroku, the time that your request spent in your proxy forwarding load balancing system, and then the request has to go backwards through the router or the load balancing system or whatever, and none of that time is effectively being measured by that internal application metric. In our case, it turned out to be something like 2 or 3 times as much time was getting spent in the rest of the stack that wasn't our application, because our application was super fast. Like, the app responded in 20 milliseconds, but an actual request, complete round trip, took somewhere between like 100 and 250 milliseconds, which that's a lot more time spent not in our app than in our app. So if you're like looking to optimize your application, really good idea to have some outside measurements as well as some inside measurements, because it might be the outside is actually what's making your app slow. I know it's Ruby, that's never supposed to be the case, but sometimes it could actually be the case. So once we'd figured all of this out, before using Puma, we wound up going with Unicorn with like 16 child workers, just so that we could try and handle more than one request at a time, which was also hard. Like, we had to double dynos size so that we could have enough memory, so that we could run enough Unicorn, so that we could handle enough run enough processes that each dyno could actually handle a bunch of requests simultaneously to make up for the router. Happily, all that's over now, and we're just back to Puma and threads. So everything's good now, right? We hope, maybe, well, mostly. And then some strange bug reports started showing up. Yeah. So we weren't really sure what was going on, but people started complaining that Bundler was doing completely weird, insane things, like, I pushed this gem and then ran bundle install, and that gem doesn't exist, and this gem has been yanked for 3 weeks, and Bundler just installed it, and that's completely wrong. Why are you so stupid? Turns out synchronizing is really, really hard. Now that we were an external service, not part of RubyGems anymore, we thought we had set it up so that RubyGems would tell us when there were new gems or gems had gotten yanked, and that wasn't actually happening. So the first problem was that syncing that in the background was really, really slow. It would take like 20 minutes because it had to download the entire list of every gem ever and then literally compare that entire list to our entire database, 1 row at a time. Is this gem there? Did it get yanked? Then we should remove it. Is there a new gem? We don't have an entry, we should add it. It took like 20 or 30 minutes to do this, and it tended to crash when it used too much memory because Heroku has small memory limits. So after discovering that that didn't really work and that webhooks are pretty unreliable, we wound up using both a background process and webhooks, and that turned out pretty decent. So most of the time when you gem push, you can then bundle install that gem in the next like 5 seconds. So in the end, we did a ridiculous amount of work, but bundling is now actually pretty fast. So like the request time went from 2 seconds most of the time to 20 milliseconds most of the time. That's a pretty good improvement. I like 2 orders of magnitude improvement. That's pretty good when you can get it. So having said all that, I mean, it's okay, I guess. We can do way, way better than what we have now. And we actually have a plan. I spent a long time talking to RubyGems and Bundler guys and made a plan and submitted that plan to Ruby Central, and they gave me a grant to spend 1 day a week working on the plan for the next, or for 6 months total, which is about the next 2 or 3 months. But I can't do it all by myself, even with 1 day a week. So you could help. Everyone uses Bundler. If you want to make a big impact on the Ruby ecosystem, making Bundler better is a really good way to make everybody's lives better, not just yours. If you are interested in helping us out, talk to me or somebody else who's on the Bundler core team, and we would love to have your help getting the next generation of Ruby gems and Bundler infrastructure set up. It's actually going to be pretty amazing. Thanks.